Today we want to look at the product rule, and in a few minutes we will look at the quotient rule. And these are the rules for finding derivatives of a product or the derivative of a quotient. It's not quite as straightforward as the power rule, but it's not a difficult thing to do. The theorem says that the product of two differentiable functions and I will abbreviate differentiable, the product of two differentiable functions, f and g, is differentiable. The derivative of f times g can be expressed this way. The derivative of f times g is the first function times the derivative of the second function plus the second function times the derivative of the first function. The first function times the derivative of the second plus the second times the derivative of the first. So let's just look at a function here that is a product and apply the derivative rule. Now obviously you could FOIL this, but there's times when that is not a convenient option. So remember, we always want to label our derivative. We're working on the derivative, so it's no longer f of x, it's f prime of x. So we take the first function times the derivative of the second plus the second function times the derivative of the first. Now those derivatives are relatively easy to find, so let's find those derivatives and then multiply. Okay, so we have f prime of x equals 2x minus 5x squared, and the derivative of 4 plus 6x is just 6. Plus the second term, and the derivative of 2x minus 5x squared is 2 minus 10x. And now we can simplify 12x minus 30x squared. Here we have to FOIL 8 minus 40x plus 12x minus 60x squared, and so we get negative 30 minus 60x squared is negative 90x squared. Negative 40 plus 24x is going to be negative 16x plus 8, and here is our derivative for the product. Obviously, we could have just multiplied that out, and we would get 2x times 4x is 8x plus 12x squared minus 20x squared minus 30x cubed. And if we take the derivative, we get 8 plus 24, excuse me, let me erase that. This combines to what, negative 8x squared? So we would have, I don't know if I can bring it up, minus 16x minus 90x squared. Notice these are the same. And if you're given an option and you choose to FOIL it, sometimes that's quicker, but that's not always going to be the quickest case. Let's look at another option here. Here we have y equals x times the sine of x. So I have a product, first term, second term. So when we take the derivative, it's the first term times the derivative of the second plus the second term times the derivative of the first. So we get x times the cosine of x plus sine x times 1. So our derivative is simply x cosine x plus sine x. In this particular problem, there's no way that you could work it other than using the product rule. Now we could do something similar here. If y equals 2x cosine x minus twice the sine of x. Okay, here we have the product rule, first term times the second. And this is just a constant, so we don't have to use a product rule right here. So y prime is 2x times the derivative of the cosine of x plus the cosine of x, don't forget to finish out the product rule, times the derivative of 2x minus, now the derivative of the sine is the cosine, so we're finished with this part of it. We'll have the derivative of the cosine is a negative sign, so we have negative 2x sine x. And the derivative of 2x is 2 plus twice the cosine x minus twice cosine x. So this derivative is simply a negative 2x sine x. Okay, we want to look now at the quotient rule. With the product rule, order did not make any difference, but with the quotient rule, order does make a difference. If we have the quotient of two differentiable functions, f and g are both differentiable, then this is also differentiable as long as the denominator is not equal to 0. So, as long as f and g are both differentiable functions, f divided by g is differentiable as long as g of x is not equal to 0. To take the derivative of f of x divided by g of x, we take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. All right, so let's look at y equals 6x minus 7 divided by 2x squared plus 3. And we want to take the derivative of this function. So y prime equals the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And don't forget, that's all over the denominator squared, which in most cases you'll never have to multiply out. Okay, so let's go ahead and do this. 2x squared plus 3 times 6 minus, now the derivative of the denominator is 4x times 6x minus 7. And no, you cannot cancel this, one of these, with that 2x squared plus 3. You have to multiply out the numerator. 12x squared plus 18 minus 4 times 6 is 24x squared. Pay attention to carrying your negative. Negative 4x times negative 7 is plus 28x. Over 2x squared plus 3 squared. And we can simplify, and when we simplify, we get negative 12x squared plus 28x plus 18 all over 2x squared plus 3 squared. And here there is no real benefit to factoring out 4 or 2 or anything, so we can just leave it like that. I would not multiply the denominator out. There's no benefit to doing that. Okay, again, I would caution you here, be sure you use parentheses, because when you distribute, you have to distribute the negative as well as whatever happens to be in front. And order is very, very important. So let's look at another problem. Let's look at y equals 3 minus 1 over x plus 5. Probably our first step here is to rewrite this problem to make it a little bit simpler. I don't like that complex fraction, so I'm going to multiply the top and the bottom by x. And when I do that, I get 3x minus 1 over x squared plus 5x. And now we can take the derivative. If we find the derivative with respect to x, remember it's the denominator times the derivative of the numerator, which in this case is 3, minus the numerator times the derivative of the denominator, which is 2x plus 5, all over the denominator squared. So if we simplify, we get 3x squared plus 15x minus, again, I'm going to put big parentheses around here so that I remember to distribute my negative after I've multiplied. 3x times 2x is 6x squared plus 15x minus 2x is 13x minus 5 all over x squared plus 5x squared. If you want, go ahead and change this to a plus and distribute. Save you from writing another step. And dy dx equals 3x squared minus 6x squared, 15x minus 13x plus 5 over x squared plus 5x squared. Don't forget your denominator. And that is our final answer for that problem. Now, many times you can simplify before you find the derivative, so it may not always be necessary to use the quotient rule. And usually if we don't have to, it's easier to simplify first. For instance, if we have y equals x squared plus 3x over 6. Anytime all you have in the denominator is a constant, you can rewrite so that you don't have to use the quotient rule. Okay, now this is much easier to take the derivative of. Here, y prime is going to be 1/6 times 2x plus 3, which equals to 1/3 x plus 1/2. Much easier than using the quotient rule. If we have y equals 5x to the 4th over 8, again, we don't have a variable in the denominator, so I can rewrite this as 5/8 x to the 4th. And now it's a simple matter of just using the power rule when we take the derivative. 4 times 5/8 is going to be 5/2 x cubed. And that is a lot simpler than using the quotient rule. Okay, now here's another problem. Y equals -3 times 3x minus 2x squared all over 7x. Now, initially you might think you have to use the quotient rule, but if we simplify this, we'd have -3/7 times 3x minus 2x squared over x, and this can be simplified further, -3/7 times, notice there's an x in every term. I can factor out an x, and I'm left with 3 minus 2x. And now that's going to be easier to get a derivative of. You'll have -3/7 times -2. And so our derivative is actually 6/7. So again, we want to simplify before we try to take a derivative. Same thing in a problem like this. Y equals 9 over 5x squared. You can use the quotient rule, but you can also rewrite this as 9/5 x to the -2, and so that is a little bit quicker to take a derivative of. Y prime equals -10/5 times x to the -3, or what did I do? -10/5 is not right. -18/5, which is going to be a -18 over 5x cubed. Much quicker and much simpler than using the quotient rule.